is going to continue for the next 2 years. It's being implemented in many places in Europe. We have 9 partners in total. Ukraine is one of the new countries actually where we are starting to use the green certification schemes we've developed in the previous years. In total, our project have about 20 partners from 2 rounds of EU funding. Now we are on our second round with 9 partners. And just very quickly to give you an understanding of what we are trying to do, the project is basically a middling between the developers and the banks, and with provision of green certification. We are trying to make these partners to meet together and to create new types of financial products which could be used to finance highly green buildings. So our consortium is bringing the know-how on the table. Most of our organizations in this project are green building councils, organizations with background in finance, organizations in the background in green housing. And Romanian Green Building Council is who's the organization leading this consortium. It's also providing you with these courses you are going to be participating in today. I can just also say that this is not the last course. We still are planning a few more courses in the upcoming year. We also hope to do a second round of these courses quite soon. So if you missed any of them, there still would be a chance to participate. And with this, let's move on to today's course. I would like to introduce our trainer for today, Daniel Armenciu. Daniel is Vice President at the Faculty of Interior Architecture at Mincu University in Bucharest. He has many years of experience in academia. He is the author of many publications and presentations on the topics of sustainability, universal design, museum design, contemporary insertion on historical sites. And so he's very passionate for many years about the green and sustainable architecture. I'm personally very curious to hear his presentation, because in the previous rounds we did hear a lot about sustainable building sites and the basics of green housing. So now I expect that we are going to take our knowledge even that one level up and focus on some beautiful architecture and design. So Daniel, the floor is yours, and we are ready to start.
Thank you so much, Eva, for your presentation. Good morning to everyone. I'm very glad that there are so many participants and that I have the occasion to show and to talk about these very interesting subjects from my point of view. Also to people outside Romania. So I'm very glad for these international programs that have this subject, very common subject, and nowadays a very important subject. So I will start now showing my screen. Just a moment. I hope you are able now to see my screen.
Yes, we are.
Thank you. Okay, so as you know, the presentation is dedicated to green design principles. And me, from the position of an architect, I would like to express some knowledges that I had the occasion to learn about during my professional life. And because I am architect, I also teach architecture. I also teach sustainable design, also object design. I would like to share my point of view from the architect's point of view. So our meeting will be just a moment. Okay. So our meeting will be dedicated to this subject, and as learning objectives, we have these 5 points. For example, I would like to have one introductory stage about the most essential aspect of building, which is the man or the communities, the individuals, people that share different types of activities in different types of buildings with different types of functionalities. Then would also like to present some very general aspects regarding the sustainability adapted to architectural design, and to express something about how can we implementate some green design aspect to the building design general issue. Then some aspects regarding the fact that architectures of buildings in generally should be very wisely integrated in a certain context, and we will have a focus point on bioclimatic design, so the way in which we can adapt building in different sites, having also always in view the fact that in each point we have particular characteristics of the climate. So buildings should be adapted to a particular type of climate with different conditions. Then I have short presentation integrated in this course regarding the way in which Romanian architecture has been developed in different types of context regarding this aspect of climatic integration. And in the end, if we will have a bit of time remained, I would also like to show you some case studies. So, seeing that we have 3 hours for this lecture, it is possible that I will not be able to present everything that is kept within this presentation that will be provided to you. I don't know if you already have it, but at least at the end of this lecture, I would suggest to the organizers of this meeting to send the presentation to you. And quite at the end of the lecture, you will receive a test. I already sent this test to the organizer, and my suggestion will be that after we close the lecture, you answer the test and you send this document to the organizers, and they will forward all the tests to me. This is a part of the program. So in order to have the credentials and so on, it's good to also to answer to these tests. Okay, so regarding the course agenda, we will have an introductory part where we will talk about general aspect of sustainable development dedicated to architectural design. Then we will talk about some aspects regarding the principles of sustainable design. Then we will focus on bioclimatic design strategies. The test will be somehow dedicated to this part, which is the most, let's say, the most I cannot find the word in English, but the one that actually enclose all the information that I will provide. And at the end, as I said, some case studies and test the theoretical application. Regarding the case studies, they are images with different principles that have been already applied to the buildings, different buildings. Okay. Please, at any instant, if you have questions, if you have any doubt, or if you want to clear a particular subject, just raise the hand or just write in the chat, and I will only hope to see that there are messages in the chat, and at an instant I can answer to that. We all know that we share this planet. This is a planet with particular conditions where our race has been developed in a very complex ecosystems. These ecosystems have been developed due to some particular conditions, I would say climatic conditions. And regarding to this aspect, I guess that we have a we as professionals, we have a huge responsibility regarding the fact that we really need to protect this planet, which is in fact our home, our common home. There is a very wide literature regarding this subject, the way in which man, climate, and architecture are relations. Because from the very beginning, from the very starting point of our race, we looked for shelters. That is maybe one of the first acts of architecture. The fact that we as individuals or as communities, we were looking for shelter, for protection. And architecture was able to develop in a very complex manner until nowadays in order to cover all our needs. Regarding to these aspects, because all the nature is developed according to a certain climatic condition, in each and every place has very particular climatic conditions, actually human races and communities and maybe even human behaviors have been developed regarding this type of connection with the climate, with the place. So this is maybe one very important reason to understand why architecture should be related to the place, to the nature, not as a closed element, like functioning like a machine, but integrated in a very natural manner. And I guess that this is one very important aspect when we think about designing new buildings. How can we do it in such manner that the building will not be hostile to the place, but it will be in a very natural manner integrated in this context. And this is, as I said, a matter of responsibility for professionals, but also for the whole communities and political authorities, because in the end, when we talk about sustainability, we talk about integration. integration in nature, integration in a certain cultural context, in a certain economical or social context. If we try to understand a bit our planet and the path, its history, and now I'm talking only about the planet, not about the people, because this is the graph regarding the temperatures of the planet, of the let's say atmosphere that surrounds our planet, starting with 500 millions of years ago. We see that we find these 5 stages. In these 5 stages, actually, the planet reached a certain balance in which we find today. Actually, humans appeared, if you see my mouse, appeared in this point here. So if we compare a bit the whole history of the planet and the known history, so the recent history, actually we can be able to understand the fact that these contexts that we know today, or the context that we know for 1,000 years ago, is a very particular and different way in comparison with all the history of the planet. So regarding the human history, we can see here also the temperatures of the atmosphere, and of course is related to the concentration of CO2. So the as we know, the temperatures grew in these last some 20,000 years. But what's very interesting, if we compare it to the whole history of the planet, the fact that this growth that we see here is for the very first time due to the fact that human activities are changing this aspect. So for the very first time in the history, human activities are the ones that are influencing the balance of the temperatures around this planet. And this is maybe one other reason why we should be very much responsible for our decisions regarding the environmental aspect. So these are 2 possible scenarios. If we take measures today, we can, let's say, have a balanced future. But if we don't, if we continue in the same manner, there might be possible that we reach very high temperatures that we cannot control anymore. Maybe we will not have an extinction of life on planet and so on. I'm not that negative, but for sure these changes happen very fast. Maybe I guess you noticed that in these last 10, 20 days, the climate has changed quite well. Now, regarding the impact of people, there are also some historical traces. It shows the fact that humans have always impacted the surroundings. And this is one extract of the Gilgamesh tale, which is written on a stone, and where we have this information about the fact that the Gilgamesh, who was the king of the Sumerians, he defies the gods by saying that uh, when cutting the trees, cutting the forests for agricultural reasons, actually they knew they created this phenomenon of deforestation, which actually lead to desertification. And this is something with which we also encounter nowadays when we abuse of agriculture in in an unsustainable manner. So if so many years ago people realized that their actions are influencing the equilibrium of this planet, so it's very important today to take some actions. Even in the 18th centuries, we know this story of this phenomenon of Easter Island, where because the community grew very much, they consumed all the resources, and due to this problem, we had an extinction of the people here. Now we know all these statues, which are very scenographic in this island, but it's important to know that this island once has been inhabited. Regarding the architecture, as I said, we always look for shelter at the very first manifestations of architecture. Actually, humans used to adapt to the natural environment because they didn't have the knowledge to build buildings. This knowledge has been developed in a very long time. So, you know, in the first stages of humanity, people used to live in caves, to decorate the caves, and to develop a very interesting, let's say, universe of living in this type of context. With the passing of time, when developing new systems, when discovering new techniques of buildings, humans have reached for different types of instruments. They discovered different types of instruments which help us to better understand the environment, the natural environment, but also to better control this environment by using knowledge. In this image, we have this view of so-called analemma, which is in this case, the overposition of these different images with the sun position on the sky. Now, if we study during 1 year this aspect, we can obtain, by overpositioning the images, we can obtain this sort of image, which is very important for understanding our relation with the sun, with the most important star that provides so much energy for our planet. Of course, when trying to study the whole history of buildings and cities, we are able to understand how different civilizations developed their very important heritage from the economical, social, cultural, religious point of view. And for example, the Greek city, the Acropolis of Athens, is maybe one very interesting case study when where we are able to see the way in which this society decided to divide the interest on different types of buildings. Right on the top of Acropolis, we have the very much important of the religious center on the top. Here, all the actually here was invested the most important um, part of the let's say resources, because they understood that this is the most important part of their word, the religious part, so their beliefs, which used to remain for so many centuries. Down below, on the base of the Acropolis, we have buildings that have been developed with less um, less important resources. And if we compare this aspect with the way in which we see sustainability today, maybe it's an important question mark to understand how and where to invest different types of resources. When we talk about resources, of course, we talk about economics, about material resources, about knowledge, people, and so on. So, in when trying to understand the instruments with which we are able to define our built environment, first of all, it's very interesting the fact that humans um, had this very tight relation to the environment, with the environmental aspects. For example, with the sun. The first elements, the first buildings dedicated to the sun were the obelisk. The obelisk is a monument dedicated to the god of sun, and because of this, actually our ancestors were able to understand the sun path movement, to understand this geometry that has been that has been developed for lot of millions of years in a very cyclic way. Well, starting from this understanding, the next step was to create a science that is also used in the building system, in the building environment. So maybe in a metaphorical way, we can say that these are the first examples of solar architecture. Some monuments exposed in the urban context, dedicated to the sun. The subject developed in time. It has been kept as a symbolic element, and it was very much refined until this very refined type of architecture, which also shows a very detailed knowledge about the sun geometry, reaching this point that in a very particular moment of the year, the sun would enter in a tomb, in a very small hole, reaching right the king's tombs. So, in order to create this, of course, it needed a very detailed knowledge about the sun geometry. In centuries, the whole context and the very complex context of architecture have been developed in such manner that now we talk about bioclimatic design or solar architecture. So these types of buildings that are designed in such manner that they answer to some natural premises. In this case, in Mesa Verde, Colorado, we have these examples of buildings that have been integrated in this natural cave, open natural cave, in order to have a natural and organic solar protection. If you see here the shadows, so during the summer when the sun is up, all this area is protected by the sun rays. In winter, when the sun is going down, actually the context is changing, and the buildings are exposed to the sun energy, to the solar energy. So we can mixture this knowledge about the natural aspect in such manner that we can reach natural energy in a very cheap way, only by using these simple principles, which actually our ancestors knew about. When we go forward to modern architecture, we have some very important architects that developed new ways of buildings, new ways of defining or designing buildings in a scientific manner. This time, in modernity, we are already in the 20th century. We were able to control in a scientific manner the aspects of the climate. And these are only some examples of how Le Corbusier, one of the most important architects of modernity, used to define the drawings of the buildings in a very tight relation with the natural aspect, the climatic aspect. Contemporary architects, in this case, like Renzo Piano, he designed this sketch, which is the sketch of a very important building in New Caledonia. It's a cultural center, developed in a very rural area on an island, related to an ancestral society. So we have here one expression of the fact that now, so today, architects are able to include the sustainability aspect in their design from the very first sketches. And actually, in order to reach very good answers and very good responses to the sustainability requirements, actually it's very important to think about all these principles from the very first sketches of the buildings or of our cities and so on. Right here in the right image, we have the way in which this sketch has been developed and designed. As you can see, there are these very big structures made all in wood, but following contemporary building methods and techniques. What's very interesting is this type of relation with new and the old techniques, all working together in the same context. This is an interesting example of how, in contemporary design, we are able to adapt or to interpret the old techniques using the same materials. For example, here wood has been used for the old and for the new building in the same context, but of course following different rules, maybe adapting to new functions and to new responses to these very new types of architectural programs. Now, starting with this very interesting subject, I would challenge you a bit to see and recognize some interesting aspects regarding the way in which old buildings, very basic typologies of buildings, have been developed in different type of contexts. In this case, we have the igloo. It's one of the most well-known type of building, which has been developed in this very particular type of context, cold with snow and ice. So it's a building which follows some very basic principles. For example, I would start with shape. This shape of the vault, of the cupola, is indeed very simple to obtain. And if we study a bit the old history of architecture, we are able to find a lot of cupolas built in a very easy manner, in so many times using not so many scaffoldings. Because as a principle, it is very easy to build just starting from the base and putting the material until you reach in the top. This type of shape respects all the laws of mechanics, of the effort, of gravity, in a very simple shape. It's important to relate the material, in this case the snow, the ice, with the shape. So imagine that we have these bricks made of snow that you put over and over until finishing and describing this half of a sphere. Now, the material is very important here, and you will see that in when we are interested in finding out some of the sustainable principles. One of the first aspects, one of the key aspects, is what type of material do we use? The response is always the site. We use the materials that we find on the site. In this case, we have the snow, we build with snow. Of course, the snow resists because we have a particular climate. For example, in Romania, we have a very top place in the mountains where it's always cold, even in summer it's cold. And during the winter only, they build this ice hotel where you can go and stay there for one or more nights. During the summer, even though it's cold, that ice, of course, cannot stand because the climatic conditions doesn't support it. So it's important to adapt one type of building to the place, to the climatic conditions, and cover the needs for a particular time. In this case, the igloo is one type of building that cannot be used forever. It is not very resistant in time, but it's sustainable because it's easy to build, it's fast to build, and it resists for the time that you need. You can have the fire inside. If you study a bit the igloo, you will see that right here on the top there is a hole. So the air can enter here on the base. It can oxygenate the place, so the fire can also be maintained and the smoke will go out without melting the ice. This sphere has one very important property in terms of energy conservation. I'm not sure if some of you are working in the field of audits of energy or designing the energy aspects of a building, but it's very well known the fact that compact shapes, compact building are conserving better the energy inside. So if you heat a sphere or a build like a sphere or maybe like a cube, a very clear square, it will keep more energy inside better than if you have a very wide building with a lot of shapes and so on. And from this point of view, this adapted shelter is an an optimum shape for this place. From another point of view regarding its integration in the place, we also have to understand the fact that we have these holes, so the enters in the building, which is orientated in a negative orientation, considering that the wind is coming from the back. So always this entrance will be directed opposing to the wind direction, so that it will not be covered and so on. And this is a very simple manner to adapt architecture to this type of context. Now, if we change the context, here we have the yurt, another very basic typology. We have the stepas context, so there are winds, it's quite dry, it's quite cold, and not many rains, so not many precipitation. We have community that deals with growing the animals, and this is why this building can very easily be mounted and dismounted using very let's say simple elements, building elements. As you can see, all the building is covered in animal skin. So the leather is used here in order to cover the building, to enclose the building, and to protect it. You know that when wearing leather, if the wind blows, actually this is a very good protection against the wind energy. And this is how this building has been developed. It has a circle shape so that the winds will very easily go around the building without opposing with so much force to the wind energy. It is a tight the envelope of the building is tight, so the wind or the air is not passing very easily in the building envelope. And yeah, this is another very interesting type of adapting a building to context. Let's change again the context. This time we go in a warm climate, but a wet one. So we have a high range of humidity and a lot of sun. As you can see, the used materials are the ones that, again, are very easily to be found. Because it rains a lot, we have a lot of vegetation. We have trees, we have plants, any type. So, it's all made in wood. It's raised from the ground in order to respond to the moussons, to those months in which the water levels grow. So we have these periods on which the house is being protected by water. Then we have this very interesting shape of the building and of the roof. First of all, because it's all vegetable, in order to have the water go off the roof very fast, we have this shape of the roof. So the pendants is very high, so that all the water is able to go out very fast. You know, if you use vegetables for these exposed areas, they are not very resistant. So in this case, the shape helps a lot. And regarding the orientation, you see it's a long building and it's exposed in such manner that all the facades are protected by the sun. Because of the latitude, the sun stays quite always up. So the roof actually protects the walls, the external walls of the building. You are able to see the fact that here we have some openings on the long, exposed on the long facade. On the other facade is the same treatment, and these openings are here for ventilation. Maybe you know, maybe you realize that when it's warm, when it's humid, you need air ventilation. So the air ventilation, so if you allow the air to pass through the building, the climate will be much easier to support. So yeah, this is another very interesting way in which architecture has been adapted to the climate. Another type of context. This type we go in hot, dry climate. We use materials, again, materials that can be very easily found. In this case, you have the ground, you build with ground, so with earth. We have very tight houses, but all these houses are very close to one with the other in order to create shapes. In a hot climate, it's very important to have the shape, the shadows, sorry, because the shadows are a response a good response to a better comfort zone. So when you have the shadow, you have a lower temperature. In this type of context, if you visit cities that um, built in this type of context, even in the south of Italy, in the south of Spain, you find these type of cities with very narrow streets, because shadow is very important in order to have the people having their activities during the day. Now, why is it good to build with earth? First of all, because we have the phenomena of thermal mass or thermal inertia. Because we build with earth, so with very massive elements, these elements are able to keep the heat inside the material for a longer time. So during the day and the night, between day and the night, these massive elements of the walls have the possibility to keep within the material the heat for a few hours, in such manner that when it's hot outside, you have a good climate inside, so it's quite cold in inside. When it's cold outside during the night, you have almost the same climate like you have during the day in interior. So the walls are functioning like a skin. And maybe you noticed in all these examples, the fact that the envelope of the building is very, very much important in order to keep this balance between the external and the internal environments. It functions like a skin, exactly like somehow like our skin functions. It has this ability of comfort um, control. You know, when it's cold outside, our skin starts shivering in order to heat the body. When outside is warm, our skin is evaporating humidity by transpiration. This is the last example that I prepared, and it's quite common for the Romanian context. So we have the temperate climate. We build with wood and earth. We used to cover our roofs with grass, with the dry grass, and this is also why we have these very inclined roofs. And here in the temperate climate, and it's the same thing that appears in a lot of places in Europe at least. This area, you can see here the fact that this on the south orientation, we have a sort of open air construction. This has the role to control the sun movement. And I will draw a bit here. So if we have here the section of the building, and if we have here, for example, just a moment, the sun. So during the summer, when the sun is up, all this area stays in shadow. During the winter, when the sun is down, actually the sun is able to enter through the windows in the house, to enlight the house, and to warm somehow the building. So this is a basic principle in bioclimatic design, used in these very basic buildings. I don't know because I didn't study architecture in Ukraine, but maybe you have this type of building too. Okay, before the break, I would like to enclose a bit this, let's say, opening with some general concept regarding the sustainability. So what is sustainable development? I'm sure we are all here because somehow we know something about it. So we reach the sustainability domain right in the point where social environment, economical environment, and natural environment intersect. In the very first definition of sustainability, we had these three pillars that used to cover the theme, this major theme of sustainability. Then in recent time, because of the importance of the subject of sustainability, but in the same manner, because of the importance of the cultural aspect, these fourth pillar have been added. And this is why today we talk about sustainability or about sustainable development when we reach all these four pillars together: cultural, economical, natural, and social environments. So each of our decisions, in order to be considered a sustainable decision, should pass through all these four filters. Only after reaching these four filters, we can say that our intervention or our decision is a sustainable one. So economic health brings financial prosperity. Environmental responsibility brings balance to the ecological aspect. Social equity brings cohesion, inclusion, engagement, good justice. Even cultural vitality brings creativity, diversity, heritage, innovation, and so on. So all these four pillars together are closing together a very important circle, the circle of sustainability. Of course, we have these general definitions of the subject, and I guess that this is the key of all our decisions regarding the way in which we change our built environment, always to have this question if our decisions will change the way in which the future generation will have the ability to meet their own needs. Does our decisions affect the next generation in a positive or in a negative manner? I guess that this is a very important question to make when we try to change something or to create something new or to have a political decision and so on. It is a sort of short history regarding some of the most important decisions that have been taken regarding the sustainable development issue in last 50 years, I would say. There are these international summits that talk and try to um, find new ways of going ahead. I guess it's a very complicated subject because maybe at one instant you have an economical stability or a social one, maybe you don't have another one. And I guess that this equilibrium is very difficult to be made. And I guess that in order to have it in a very organic way, to have it this center of circle of sustainability, to have it closed, I guess that it's very important to work all together. And this is why I find very important our meeting here at this international level, international changing. I guess you are aware of this agenda for sustainable development, where for the 2030 we have these 17 goals regarding different aspects of our lives. Some of them are, of course, covering also the architectural aspect. Okay, I would now propose to have a short break, and let's continue after that. Please, if you have any question at this instant, we can try to answer.
Thank you, Daniel. How long is the break? Sorry.
I would suggest, I don't know, 5 minutes.
Sounds
I think
perfect.
10 will be good.
Okay.
Okay, then 10 minutes. Then
Thank
yeah.
you.
Thank you.
Okay, so we have 10 minutes past 11, so we'll meet you everybody here in 10 minutes. So please do not switch off the conference, and we will back in 10 minutes.
Great.
Так что мы бомбу включим.
Here I am again.
Yes, we can continue. 10 minutes already passed.
Great. I would like now to have a short discussion about some important aspects, important changes that have been made on the evolution of architectural phenomena in the past, let's say, 100 years ago. Actually, we talk about three paradigms, and these paradigms are related to some changes in terms of vision about the world of the specialists in the building subject, but not only, because these types of changings have also been made at the level of society, of how people used to adapt in different types of conditions. Now, I'm sure that you are aware of the fact that in at the end of industrialization, at the end of the 19th century, we had a very wide development of the industry. We talk here about the heavy industry, about a period when appeared very important new types of buildings, which used also to cover very wide openings, like the railway, the train stations, new buildings or showrooms for international universal exhibition, like we have, for example, the Tour Eiffel in Paris. So there are these expressions of a period in which industry knew, for the very first time in the history of humanity, a huge development. This development, of course, made a lot of changes from the economical to the social point of view, but even from the environmental point of view. Because in order to cast iron, to melt iron, and to cast it in new shapes, a lot of energy, a lot of heat was needed. In order to do that, we use the coal. So the coal have been the major combustile for obtaining high temperatures and so on. As you know, when using hydrocarbons, CO2 emissions are growing very fast. And from this point of view, the industrial age, the industrial period, was great from the financial point of view, from the cultural point of view. But from the environmental one, it was somehow a mess, because CO2 emissions used to grow very fast. And this heavy industry has a very big inertia, because even today we use these resources, natural resources, that are burned in order to sustain different industrial activities. As you know, one of nowadays paradigms is to change this type of resources and to pass to the alternative energy. But in order to do that, we all see that this is a very, very difficult subject. Now, the ecological paradigm, which appeared at the beginning of the 20th century, was a response to this type of context. This is why this sort of way of thinking was focusing on the power of ecology, the nature and the health of people. The next important paradigm was the one related to bioclimatic design and use of energy. From this point of view, let's imagine the the energy crisis in the 60s, 70s. We had this very unpleasant context where for the first time, actually, people realized at a very international scale that these resources based on hydrocarbons are not here forever. We cannot use them forever. And this was the moment, a crucial moment, when the paradigm changes. And for the very first time, we tried to find reasons and ways to use alternative ways of energy. Then we have another paradigm, the environmental one, the one in which, from the historical point of view, we are now today. And today, actually, we try to have an holistic approach on the sustainable development. And I'm trying a bit to talk about each of these paradigms. The first one, as I said, was focused on ecology, on reinventing our connection with the nature. We had these examples like the Falling Water House, designed by Frank Lloyd Wright, who tried to find an alternative to the development of the cities in very unhygienical conditions. So he tried to repropose new ways of living outside the cities. The middle of nature, where of course you have a very natural environment, a clean air, and so on. But of course, this type of approach was focused only on this power of ecology and not on other problems that also appeared. So we talk here about ecological architecture for the very first time. And at the same time, we talk about the values of vernacular architecture. Vernacular architecture is the one that has been done for centuries in a traditional way. Vernacular is somehow similar to tradition or to authenticity. Actually, those examples that I showed you, the different typologies adapted to different climates, those are integrated in this typology of vernacular architecture. Later, when, as I said, we had these problems of understanding the future of resources, new alternatives used actually entered in discussion. actually also new ways of building, new ways of simply imagining how a building should look like was reinvented. We have these prototypes of buildings that are able to be open toward the solar energy, to absorb as much of energy as it can, as the place allowed, in such manner that you can also reach houses that are independent from this point of view. So they can be autonomous. They can only function with the energy that you have on the place, without using the natural gas, the oil, and other types of conventional source of energy. In order to do this, it's important to have a very wide and deep understanding of engineering, of the building physics, of the systems that can be integrated in such manner that they will very deep help you to design a new typology of buildings. So from this point of view, there are methods of rationalization of energy. And when we talk about this subject, we should include also production and also consumption, because on one side, we should be attentive to what sort of devices do we have in the house, in such manner that you reduce the consumption. But on the other side, it's very important to have a very wisely designing of the production system. And now we talk in this type of environment about bioclimatic design, bioclimatic architecture, which also can be very easily related to the vernacular design, because there in the traditions you have the basic principles of building. How do you orientate the building? What type of relation should you have with the environment, with the winds, with the sun, with the rain, with the snow, and so on. And as I said, the most common and the most actual paradigm is the environmental one, when we talk today about holistic approach of sustainable development. Here appears one very important key aspect, the life cycle thinking. When you think about the resources and you have in view not only the resources that you need for obtaining the energy for the heat and for heating or cooling the house, but also about the materials with whom you design the building. And of course, when you talk about the materials, you should be focused on the materials on the site, on the distance that you have from the basis of the extraction of the material to the site construction, and so on. So from this point of view, a wide engineering and also legislation has been developed in order to find out which is the footprint, the ecological footprint of the building, taking in account not only the energy that you consume, but also the integrated energy that has been consumed while building the construction, while producing the materials and so on. Now, regarding the nominations, we are able now, if you read the newspaper, if you read a magazine or an article on the internet, we are now able to find so many titles like green architecture, sustainable design, eco architecture, solar architecture, and so on. There are so many titles. But I guess what's important is, first of all, to understand the concepts, the main concepts of sustainability. And here I mean, which are the 4 pillars of sustainability that I previously talked about. And regarding these very pointing titles, I would only suggest that they are, or they might be, different types of approach to one building, or approaching one particularity that enters in this wide umbrella of sustainability. This is why I don't think that we should pay that much attention to the nominations, but it's better, it's much more important to have a final result that enters in a very organic manner under this umbrella of sustainability. We have, for example, principles, different principles or concepts when you design a building. This is one example of what American Institute of Architects used to define for obtaining a sustainable design, sustainable architecture. And you can see here are 10 points like design innovation, regional or community design, land use, site ecology, bioclimatic design, and so on. I will not put the accent on each of them. But it's important to understand that in order to fulfill all the aspects of sustainability, it's important today to have this holistic approach, to pay attention to different criteria that can be included in your design, and very important criteria that are adapted or can be adapted to your site, to the climatic conditions, to the social conditions, and so on. From this point of view, there are, of course, different authors that talk about the concepts and so on. But I think that today it's very important to cover these basic principles of ecology for ecological compatible architecture. Because when we talk about architecture, we mainly refer to the built result. So the built result should be comfortable and healthy for the people that live inside or have different activities inside. Then this building should be accorded to the ecological values. When you have a brownfield, for example, your intervention should transform this brownfield into a greenfield. When you have already a greenfield, it's very difficult to have a sustainable intervention because actually you change all the natural values of those places. Then the building could include passive or active design systems. It's important to adapt the energy use to the renewable systems, so not to be dependent anymore of the old, the conventional systems. Then it's important to use sustainable materials. materials that have a very low impact on the environment, materials that can be easily recycled or reintegrated in this cycle of materials. And now we talk a lot about circularity, about circular economy, and so on. So this is a big change in the paradigm of building. Of course, when we talk about cycling, life cycle thinking in general, it's important to evaluate the ecological footprint, but also the costs, because, as I said, you cannot pay attention only to only one criteria or only one pillar of the sustainability, but we should take care about the whole system in an holistic manner. I think that when you start designing a building, it's very important to have this to include from the very first the principles in a very innovative type of design. Now, regarding the bioclimatic design principles, which are the basis of the shape of the building, of the orientation of the building, and so on. So, the wide question mark, how can we do it in an innovative manner? Tradition is helping us a lot. These principles are valuable for centuries, so we are able to use them. But we also have technology. So the technology help us a lot in innovation. New materials, new ways of techniques, new ways of combining materials. And only by using the principles of physics, of thermodynamics, of energy movement, and so on, we can define new ways of innovation. The bioclimatic design is, in my opinion, the key of obtaining a great sustainable intervention. Because from the very beginning of your design, you define the shape of the building, the materials of the building, the orientations of different aspects, the way in which you have the street, the dimensions of the street, the green, the plants that you have on the street or on the building, and so on. So by using these principles, actually you are able to define a whole system of the built environment tight connected to the nature, because nature has already been developed according to the climatic conditions. So the building should do the same thing. The building should be integrated in a natural and organic manner to the site, to the climate. And this is what actually bioclimatic design talks about. It talks about building with climate. In this very suggestive image, we have here the central point of the project, the people, the ones for which we design. Then we have the shelter, the house, the building. In order to achieve the perfect comfort and health and so on, our buildings should function like a sort of filters, like a sort of intermediary environment which stays between the body, our bodies, and the natural environment. And in this scheme, we are able to divide a bit this natural environment into districts. On one side, we have the bioclimatic architecture district. And here we talk about everything that is connected to the climate. And these are those elements that help us in obtaining the human comfort. On the other side, we have another district which is called the biophilic architecture district. Biophilic is related to the nature, to the ground, to the water, to the vegetation, and so on. All these elements, also the food that we eat and the water that we drink, they all connect our bodies with nature, and it covers this need of health. So the human health related to the biophilic architecture district, which from one point of view, this is the ecological field. So I think that this scheme is very important in order to understand which are the stages or which are the areas of interest for different aspects. Bioclimatology is indeed science, the science that studies the influence of climate on living being, and it has been extended to this knowledge about bioclimatic design, which relates the built environment with the climate, with the nature. And these actually should be understood as a particular approach. We take care about the climate, we take care about some aspects that provide a comfort for people, and it's not enough. In order to have sustainable integration, as I said before, we need to cover also other types of criteria, but this one is one of the most important criteria which influences the other types of criteria. Now, I included here some aspects regarding the way in which we are able to define architecture. I will not focus very much on it because it's also a lot of information about the management of the project and so on. So I will pass a bit faster in this area because I would also like to cover some case studies. So it's important when you take decisions, and of course when you talk about the management of the project, you take decisions. All these decisions is important to be filtered, as I said, in the 4 pillars of sustainability: culture, environment, people, and economy. All the process of designing is a cycle, because you have different phases. Each phases should take you to the next phases, and in this manner you define a circular and organical aspect. Now, as a general phase, and this is only a very schematic and very important diagram regarding the path of the designing. So first of all, you have the site. You know that you need to design a building in a particular site. So you make the site analysis. First of all, it's important to understand that site from all the most important points of view: bioclimatic, I don't know, impact on environment, social, economical, and so on. Then, at the end of the analysis, you have some strategic criteria you can work with. These criteria are related to the green design principles. So it's very important to understand these green design principles in order to apply them to the criteria, to the results of the site analysis, in such manner that you choose the strategy in which you design. After choosing the strategy, all the scenarios of how the building will function, only after you define its aspects, materials, some particulars, the aesthetics, and so on. But in order to have a sustainable result, it's important to introduce these green principles somewhere here in the definition of the strategies. This is only a view of how, at a very schematic level, you can integrate these strategies which provide comfort for the inhabitants, which help the building to be much more integrated in a context in such a manner that it also uses less energy and better it uses alternative ways of energy. Okay, I talked about the impact of the man and the fact that actually the wide problems of the environment, unfortunately, are influenced by our activities. This is why it's important to have the correct decisions. So, in order to have the correct decisions, it's important to have a wide and correct analysis. When analyzing the site, we can divide or we can approach at two scales, two levels. On one level, and we have here the scale A, which is related or which is, let's say, somehow the relation between the individual, the man, the community, and the building. So it's more about the inner life of the building or of the built environment. And the other one, at a wider scale, is the relation between the building and the environment. And we can, here is a division of different criteria of analysis that we can have at a wide scale. On one side, environmental and cultural analysis, and on the other hand, the bioclimatic analysis. We will only touch some principles for each scale. At the scale A, so relation between man and architecture, we have on one side the analysis of the function of architectural spaces. So, of course, from the very beginning, we should know what type of functions do we need? What sort of integration can we make? So, the theme of the project, the program of architecture, will be related, of course, to the functions. Then, the human activities. What human will do in the building, in the different types of spaces? How can we achieve the human comfort by using different, let's say, ways of analyzing the comfort? And one important is the psychrometry, which follows the relation between the thermal and the humidity. So the thermic and the humid, which is one of the most important comfort aspect in the building. Of course, there are others, but they are not included at this stage because they are particular analyses that you should make, or you should define depending on the spaces that you have already done. It's something that you integrate after the concept was closed. Scale B, analysis of environment. So on one hand, you can study the heritage and the cultural landscape, the material or the immaterial heritage, ecosystems, life cycle of natural resources on a wide scale. You can define a certain circle around the building, around the site, and you can decide, I don't know, for example, I would only use materials that can be found in a radius of 100 kilometers. It can be an interesting criteria, not to bring materials from Cuba, I don't know. Then, pollution and wastes. This is a very important aspect in controlling maybe the site is proper to be used for a new building, or on the other side, which are the pollution and wastes elements that our building can produce. So these analyses are not only related to the existing condition of the site, but also to the future conditions after the building will be functioning. And the bioclimatic types of analyses, which will particularly, of course, talk about the local climate, about the temperatures and humidity ranges, about the winds and the solar radiation, about nebulosity, albedo, and soil, which are somehow related to the solar radiation, the precipitations of how much it rains, how much it snows, and of course about the terrain morphology, how the building can stay on the site. If it's a flat site or an inclined one, if you have the mountain or the fields, it's important to adapt all these elements because the building will respond always in a particular manner in each and every particular site. These are criteria that are very important to be integrated if you want, in the end, to receive the greatest results in terms of sustainable integration. And in order to do that, it's important to see how do you work with these analyses and how can you define the project itself. You can use different criteria and different ways of interpretation of the analysis results. It's important, first of all, to work on the functional aspect, and then on the relation with the site, the way in which the building will work together with the environment in a manner that takes in account also the volume of the building, the relation between the spaces, and in the same time, it's important to see how do you combine all these elements with the regulations of the countries, because each country has its own norms. So it's very important also to adapt these elements. It is, I would say, a complex aspect, and I will only mention it because if you enter in it, it becomes much more complicated. But maybe the most important aspect to mention is the fact that when defining the building, let's imagine building an office building. It can be complex because it can include also a conference hall or a meeting hall. It could include a lot of offices, garages, so parking plots and so on. So there are different functions that can be included. So how do we combine all these in such manner that you obtain the optimum integration, the optimum combination of these functions? So we can use diagrams, we can use tables to work with, but today we have also the artificial intelligence. So the computers are able to help us in combining all these elements, and they can help us in obtaining the best, the optimum decisions. Then, in relation with the environment, after defining, let's say, the general volume of the building, it's important to analyze and to see the response of these shapes with the environment from the energetical point of view, at least. We can talk here about the light, we can talk about the heat, the winds, and so on. So all these elements are related with the building all the time, in all the seasons, during the day and during the night. So it's important when you design the building to take care about these aspects in all the time. So to see how the building react to each and every moment, and this could be quite complex, but of course you can reduce these decisions to some particular scenarios. And here is actually the place where I would like to reach, to see how do we define these scenarios. And in order to do that, first I would only mention some elements. Like, for example, in a building, how do we expose different functions? For example, in a house, where is it better to put the bedrooms, the living rooms, the kitchens, and so on? So it's actually the optimum response would be, let's adapt the activities with the sun activity. So starting with the day, starting with the starting of the day, we have different activities. We have a certain rhythm, which is related to the circadian rhythm of our body, the connection of our body with the environment. And from this point of view, maybe it's simpler to adapt our home to our activities. Like, you wake up in the morning, you are already in the bedroom. So maybe it's better to put the bedrooms in the east. Then you start defining your activities. All the day activities are better to be oriented toward the east, south, and west. on the north, it's better to have all those functions that don't need the sun. For example, the entrances, annexes, deposits, bathrooms, and so on. They can all sit on the north, but all the day activities should be better exposed on the east, south, or west, depending of the type of activity. Great. Now, as I said, let's imagine that now we close the analysis aspect, and now we need to understand its principles. So the next phase will be to understand which are the green design principles that can be integrated in the building. So these principles can also be the result of an analysis developed by a software. And from this point of view, I would suggest this software that helps you in obtaining different diagrams and so on, which helps you understanding in a very, very clear and graphical way to define which are the basis principles that you can use in when designing a building. For example, how many windows should we have for one room, for the bedroom, for the living room, and so on? How is it exposed to the sun, and so on? So all these elements are helping us to define the whole envelope of the building, the whole space orientation, and in the same manner, when related to the human activities, it can result in a great sustainable design. So we will start. First of all, I will show you very fast which are the basis principles of bioclimatic design. How can we combine and work with these principles in order to define the strategies? And then, of course, some of the basis traditional bioclimatic design as source of inspiration. Now, regarding the basis principles, this is the major taxonomy of bioclimatic design. So, principles of functional nature, principles of using the solar radiation, principles of using the laws of thermodynamics, the airflows, the hydrothermal principles, the use of precipitation, so the rain and so on. When you enter in detail, you will notice that all these wide principles are connected with the very basic principles. For example, the direct solar gain. So you use the solar energy that helps you defining the direct solar gain. This is an important principle during the winter. So when it's cold outside, it's cold also inside. So it's important to get inside as much natural and free energy. And here we talk about the solar energy, so about the thermal energy of the sun in a free manner without using the classical resources, the conventional resources. So important during the winter to have direct solar gain. But this phenomenon is great in the winter. When the summer is coming, And if you have a lot of sun inside the room, this condition is not anymore the optimal one. This is why is needed the solar protection. So you see here these first two principles that use the solar energy, but in a very different manner. On one side, it's important to integrate the solar energy, and on the other side, it's important to protect of this solar energy. Other principles. Heating. Heating itself is a very basic principle and a very important one during the cold seasons. As in the warm seasons, the cooling is. Other principles, natural ventilation. Let's integrate the natural ventilation in the house for at least two reasons. On one reason, for the introducing the clean air with oxygen, and on the other side, for cooling the building during the summer. So you can introduce the air inside the building by means of different strategies. You can cool the building only by the movement of the air. Then thermal mass is a characteristic of some materials. So if you need to make use of these principles of the thermal mass, the next step would be choosing the proper materials that have this property of thermal inertia. Heat conservation, thermal insulation. Also, they are important principles that help the heat be conserved or be better controlled in a closed environment. Acoustics can also be an interesting principle which is related sometimes with the climatic condition, because the acoustic waves are related to some properties of the surfaces of the building. So when you use some materials, they can react in different manner when the climatic conditions are changing. Natural lighting, water collecting, or water reuse, again, other important principles. Then a particular principle this time regarding to what's happening in the building with the people. So the way in which you refer or you connect the functions with the activities and with the climate. This is an important principle that actually influences the whole building orientation and opening toward different coordinates. I would close this list, but of course, it is not it's not the final list, so it can also be completed with other principles, but these are the most common ones in bioclimatic design. Use of water and vegetation in microclimatic comfort control. You can make use of water and vegetation, and this enters a bit in the area of biophilic design in such manner that by the means of the thermal and humidity characteristics, you can control the microclimatic conditions of one space. I would suggest now to have another short break, and after that we will close a bit the subject of the strategies, and then I will show you some short case studies. Is it okay? But this time maybe we can have only 5 minutes break. So I suggest you to be here at 12:21.
Daniel, are you here? Daniel, are you here? Can we continue?
Sorry, I had a small technical problem, so I'm back.
No problem, we can continue.
Yes. Just a moment. The share screen. Okay. So as I said, the strategies. We talked about the principles, and now I would like to focus on this important theme of how to define the strategies. The question of designing the strategy of a building is very important because there are different ways of managing the energy of a building. There are these defined types of strategies: the conservative, the selective, and the regenerative types. But there is also one other one, which is the exclusive one. To better understand these, there are these very, let's say, small drawings that I think they suggest very well the types of energy management strategy of a building. The conservative one is the one related to the, let's say, classical way of building. It is somehow related to the buildings with which we are used to in the old town centers, made in brick, in heavy materials, that used to be, for example, heated with stoves inside and so on. And it was based somehow on the idea of conserving the energy. It's like, imagine that you have the building with massive elements that have the ability to stock energy within them. So you heat the house, It means that you have some stoves in the house. These stoves have the ability to heat the air in the rooms, but also the walls, the external and the internal walls. All these surfaces, if they are heavy, they have the power to conserve this heat for some period. This is the way in which the traditional building used to work. From other point of view, we have this idea of regenerative or exclusive management systems. And these are somehow related to the modern age. In the modern age, the paradigms of building or of designing a building was quite different, because new materials used to appear with thin walls, with a lot of glass, with open spaces and so on. This happened also in a context where the climate was not important anymore. So in order to adapt and to obtain the comfort, in these types of buildings, you need a lot of equipment, a lot of installations. And this is why we somehow talk about the regenerative, because you need a constant regeneration of the energy, or exclusive, because you simply defy the context, the climatic context of a building. And then you have the selective. The last one, the selective type, is the one that actually makes use of all the principles of sustainable design, of bioclimatic design, which is relation to the environment, and on which actually bases on obtaining energy from alternative ways. It means that the quantity of installations and equipments will be much more lower. The installation in this case have only the role of controlling some particular moment when the alternative free and natural energy is not, let's say, it cannot face the need of the comfort. And this is why it's called selective, because actually it's like the building is selecting what sort of energy does it take. So this is the optimum situation that we should take in consideration now. Okay. You will receive all these texts because within the text you can obtain all these levels, all these information. I will not enter in details because I try to speak more on those drawings. But what's important now, after defining the correct strategy, is to divide or adapt the strategy to different particular stages. For example, defining the scenarios for different seasons, how the building will work in the winter, in the summer, or in the in-between spring and autumn seasons. How will the building act during the night or during the day? Or maybe, depending of different considerations, how will the building work in any type of context or period? So these are the scenarios that should be defined on the base of the principles. These are only some images that would try to suggest what sort of studies should be made in this stage, in the stage of defining the scenarios. So we work with sun studies for different reasons, for understanding how the light, how the heat enters in the house, if the house is covering other buildings and so on. If you maybe need to design the shadowing devices, it's great to use softwares or schematic drawings. So this aspect is very, very important aspect of sun studies. There were in the past, let's say some decades, also these possibilities of defining the sun studies by the use of these models, but now we have beam softwares. We have these softwares that define in real time levels of installation. Then you can define studies for the air movement, how the winds are behaving, how does the wind influence maybe the cooling of the building, how does they influence the external environment of the building, and so on. Then it comes about studying the hydrothermal comfort, the relation between temperatures, humidity, and air movement. This triangle, very important triangle, is or have the power to influence the comfort of the inhabitants of the place, of one place, on one space, and you can make use of softwares in order to do that. So it's a very complex aspect that cannot be done only by architects. So you need engineers, you need energy audit, and so on. They are all important to work like a team and to define together with different softwares to work and define the best strategies of the building. If you are interested in, I don't know, these types of software, this is a free software, Climate Consultant. You also have the link if you want to download it and work with it. You can make use of the climatic data that you have in one place, and you can see how you can define the strategies for different types of building and locations. Now, now that we have all these elements, I hope that I could express them in a clear manner, because also the time is quite short. Important maybe only to mention the importance of the building envelope. The scope, the principal scope is to obtain the comfort. So the building's envelope is like a skin that functions or should function like an organic element that functions like an interface between the interior and the external environment. This envelope should answer to all the climatic aspects of the building, and it should react in I would say passive way to all the reactions that are happening between the interior and the exterior, because depending also of the season, the whole building will react in a different manner. Sometimes you have a wider range of humidity inside the house, but in other seasons you have them outside. So the building and the building envelope should react to these types of exchanges. This is why it's very important to have a very technical knowledge about all the effects, about all the phenomena that could happen in this relation, and in this manner the characteristics of materials that you use, the whole layering of the envelope are very, very important. I will now, in the short time that we have, present some case studies. And I would like to start with a short study that I have done in a Romanian context. This is the map of Romania, and this area where I will also draw just a moment. So this line that you have here is the line of the corporations. You know the mountains, you know the complexity of the topography of the mountains. So here we find at the level of the Romanian country, we have different types of settlement. You have these green, orange, and red spots. The green spots are very tight related with the topography, and these are villages where you have the houses that are very distanced one of the other. Then we have the orange dots where you have the cliffs, and here the houses are much closer. And then you have the red ones where you have all the houses very, very close one by the other. It's important to mention that in these places where you have the red spot, you have flat landscape. Now, just a moment to cancel this line. Okay. I will only mention 5 important principles: solar control, air temperature, humidity management, precipitations respond, and air movement. So, Transylvania and Maramuresh, these are 2 areas close to the mountains, where you have this type of roof with high angles. Usually you build with natural materials like stone and wood. And you find this very simple section of the house. You will notice that in all the regions of Romania, we have some similarities, but also some differences. Here we have a very high angle roof. We always, in all the regions, have this area, which is like a sort of pergola. It is a protection toward the south, which is controlling the sun angles. You have the house, the heated areas here, where you have the orange. You have a protected area, which is the roof, the under roof. You have the control of humidity by the whole envelope. You have the response to the precipitation. So in this case is wide roofs that help the water to go fast out. And winds that generally come from the north. You have this interesting bivalence. On the south, you have this device, this area, and on the north, the house is closed so that it can be protected by the winds. When you change the regions, you see that the roofs are not anymore that high, but the response to the climate is much or more similar. Here in Moldavia area, we are able to find this space on the north, which protects more against the wind, winter and cold winds. In other areas, here in these areas, 2 areas, Muntenia and Oltenia, we also have a basement. It's a semi basement for fruits or vegetables deposits. And right in Dobroja, nearby the Black Sea, everything is very flat. But what's interesting, the materials of the building might change, the geometry of the building might change, especially regarding the roof geometry, the presence of not of a basement, or some annexes that are connected somehow on the north facade with the building. But in the rest, there are a lot of other similarities. This is a sort of general criteria, general principles presented on this very simple scheme where we're able to keep together all these principles that I have talked about. So thermal buffer toward the north and toward the roof, heating right in the middle of the house, closing of the inhabited space, following the conservation model of heat management, and toward the south, this interesting construction where we have this roof widely open, as I would say, toward the south. Some case studies, some projects, some of them are only projects, other of them, they are also built. This is one project designed for a contest. I was part of the team of the project. It was a very small house dedicated to a particular condition, and it was inspired somehow by the traditional building. You have here some photos of this building. You see that it has this basement. Maybe you recognize, when seeing these images, you recognize the typology from the scheme that I have already shown. Now, our interpretation was to make use of this stair that in the past used to help the access, to make easily the access from the basement, from the ground level to the main area of the building. But we made an interpretation of this scale there, in such manner that it would get on the roof. So the roof would be a green roof. It would be a garden, and the idea of having a garden on the top was the one of balancing the terrain surface that the house has already occupied. So it's somehow that idea of balancing the quantity of green. We have made some sun studies for optimizing solar energy access, and we defined the strategies. I think that this is the central point of defining the first stages of the project. We have these scenarios. In the left, scenarios of functioning during the winter. Here on the right, the scenarios for the summer. I would focus now on the winter. We see that we have this sun protection device, but it only functions during the summer, so it protects the sun rays. But during the winter, all the sun rays are able to enter in the house and also maybe heat the interior of the house. Right in the middle of the house, we have this inner space, which, imagine it right in the middle, like a tower. It's a sort of thermal buffer area, which helps to the heat conservation, and during the winter, it's more like a greenhouse. Right on the top, you have this area on which some solar panels or photovoltaics could be integrated. Then the green roof helps at allowing all the humidity of the precipitation to be collected, and then to be collected in some special devices. But I don't know if you are used to the qualities having a green roof. First of all, it also could function like a sort of thermal insulation, but it better works during the summer. And now I will pass to the description of the summer scenario. So the green roof, because you have the plants on it, will be protected in a natural manner by the solar energy. The leaves will leave the shadow on the surfaces, so the heat will not be transferred that easily during the summer. This internal tower will function like a sort of device for helping the passive cooling by ventilation. And you can see the warm air stays above, the fresh air enters in the bottom of the building, and so you will obtain a cool environment inside the building. These are some sections, some renderings, some plans. You have a bedroom with a window toward the east, all the living rooms, all the day activities orientated toward the south. This entering on the west is protected. You don't have windows on the west, because the west energy during the summer could be harsh. It could raise very much the temperatures in the interior. So this is why we didn't choose to have window on the west, but we have all these protected entrance and the stair and so on. So here is the entrance protected by this wall. I will now describe another project. I will only focus on the principles, not on the architectural qualities. So we have a greenhouse here. This is a built project. It was built for an international contest called Solar Decathlon. It was built by students, and with the help of some professors. I was also integrated in the designing team. And the idea was to have this greenhouse here, which doesn't function that much as a bioclimatic greenhouse, but much more as a greenhouse for vegetation. The idea was to have and integrate vegetation right in the middle of the house. So we have here the kitchen and here the living room. And this is the ground floor. There is also an upper floor, but it has more or less the same compartmentation. Here is the north. So right on the northeast, generally in Romania, the winds are coming from northeast. So it is why here we put the entrance, some technical spaces, and the bathroom. The other ones are widely open toward the south and west and east. The position of the windows are very tight relation to the wind, to the air movement. And we have these scenarios, like for the winter, during the day, we have the sun that enters and cools this greenhouse, but also the internal spaces. We have a heat pump that transfer the heat by some architectural surfaces like the ceilings and the walls. And this was an interesting decision to make. During the night, everything is protected, so the energy is being conserved. During the summer, the greenhouse should be protected so that the sun will not heat this greenhouse and the internal spaces. The greenhouse is being ventilated. We have a cooling ceiling and some cooling walls provided by the same heat pump, ventilated facade, and so on. So, I guess that we reached the time limit of the course today. There are inside this presentation that you will receive also some other case studies. If you are interested to study them, you can reach them. There is one in Kosovo, a very interesting neighborhood. Then there is another one in Italy. This is another neighborhood, residential ones, but also a museum. And you will see how the designer developed these buildings, very interesting buildings in the Italian context. This is also the museum. It's a natural science museum put there. And there are also some other buildings. This one is in China, where there are integrated the different principles. And they are, as I already explained, divided in scenarios. So you will have the scenario for winter. All the principles are described here, but also for the summer. So, thank you very much. You will receive, as I said at the beginning, the test. You will receive the test, so you can answer to it. I suggest you to send it to the organizer, so the organizer will forward all the tests to me. And regarding with this subject, I would suggest that we can, I don't know, we can remain in contact. At the end of the presentation, it's a PDF. At the end of the presentation, you will also receive, you will also have my email address. So if you are interested in contacting me, you are free to do it that. So thank you very much. If there are some questions, I could have some minutes to answer. Otherwise, I hope that this lecture was useful for you, at least for seeing this very particular type of approach on architectural design.
Okay, thank you, Daniel. Yes, I will send to all the participants email in shortest time. There I will include the Word document with test. It's really simple. It's only one question. You should answer. So if you will confuse with English language, so you can use some Google translation, simple words, just to make Daniel to understand what you have written. And together with that letter, I will send you all the presentation, and as usual, we will make a press release of this course on the webpage of Association Energy Efficient Cities of Ukraine. There you will find the recording of that meeting in two languages, English and Ukrainian, presentation, and some additional information. And in case you are interested in Daniel's work, you were welcome to contact with Daniel on private. You will find his email in the mail which I'm writing right now for you with that test. So maybe some questions on this final stage. Please feel free. Okay, if no questions, that I would like to say words of thanks to Daniel for his very interesting presentation. I hope all our participants found that information useful and interesting, and it will be useful for you in your private and professional life, of course. Thank you, Daniel, one more time. Please follow our next courses. We will have some vacation in our courses, New Year's vacation, and we will back with the final courses in January. You will be informed about the dates and the time of the last trainings. And for those who complete following all the courses, we are preparing some certificates as specialist in green building. You will be the first people in Ukraine with that certificates. So please follow our courses, be active. Please find in the shortest time the test from Daniel, and send your answers to the email that I will mention in my letter. Thank you, Daniel, one more time. Thank you, all the participants. Wish you all the best and peace for Ukraine and us all.
Thank you.
Thank you
very much.
Bye.
Bye.